In this module, we will be investigating parallel and perpendicular lines. Specifically, we'll be looking at the lines themselves and their slope. And I've thrown a picture up that has some parallel lines on it here in this wee tennis court. There's some parallel lines, and there is a perpendicular line. Looking at slope, we have 4 different cases. A positive slope indicates that the line slants upward or rises from left to right. And here we can see that positive slope. Conversely, a negative slope indicates that the line slants down from left to right. And there we have our negative slope. Our 2 other slopes are undefined, meaning we have a vertical line, or a slope of 0, meaning we have a horizontal line. Slopes of parallel lines, then, are 2 lines where we have the exact same slope. In this instance, we can see that our slope is 3 in both cases. However, they are not the same line. Visually, we can see that, but we can see that mathematically because they have 2 different y-intercepts. Perpendicular lines are lines whose slopes are negative, or what we call opposite reciprocals. What do we mean by that? If we look at the slope of the first line, we have our slope equals a negative 1/3. The slope of our other line is 3. We could think of that slope again, thinking about it as rise over run. We have a rise of 3 and a run of 1. We can see that 1/3 and 3 over 1 are reciprocals, and the opposite or negative part comes because the slope of our first line is a negative 1/3. The opposite of that then is a positive. We can also know that perpendicular lines have slopes where the product is a negative 1. So we can take a negative 1/3, multiply that by 3, and see that those slopes do multiply to a negative 1. These perpendicular lines also form a right angle. Lastly, we can have lines that are not parallel nor perpendicular, and we would know that if first of all, the slopes are not equal, meaning they are not parallel or the same line, or the slopes do not have a product of negative 1, meaning they are perpendicular. So when asked to determine whether the following lines are parallel, perpendicular, or neither, I'm going to be finding the slope of each line. To do that, I'm going to put these lines into slope-intercept form, y equals mx plus b, so I can find that m, or that slope, more easily. 3x minus 5y equals 25. I'm going to start by subtracting 3x from both sides. Then I'm going to divide by a negative 5 on both sides, leaving y equals negative 3x divided by a negative 5 is a positive 3/5 x minus 5. And in this case, I'm mainly interested in my slope of 3/5. How does that relate then to my other line? 10x plus 6y equals a negative 12. I'm going to again put this into slope-intercept form. Starting by subtracting 10x on both sides, I have a negative 10x minus 12, equaling 6y. I then need to divide both sides by 6, seeing that y would equal negative 10 divided by 6 can be reduced, dividing both of those by 2 to get negative 5/3 x minus 2. Again, I'm mainly interested in my slope. I can see that the slope of 3/5 and negative 5/3 are opposite reciprocals, meaning they're perpendicular. I can double check this by taking 3/5 times a negative 5/3 to see that the slopes products is -1, meaning the slopes are perpendicular.